All right, guys, welcome to our Unit 1 quiz study guide. I'm going to be going through the even problems with you guys. Those are the ones you're required to do. I'll also be including the answers to the odd problems if you want to just practice a little bit more. The odd problems are not required for your assignment. All right, let's go ahead and begin here. So, number 2, differentiate each function with respect to x. So, here we go. Before I begin taking the derivative, I'm going to rewrite some stuff here. The x squared is going to stay the same, but I'm going to change this 5 cubed root of x into 5x to the 1/3. So we talked about how you need to rewrite radicals. You also need to rewrite expressions that have the term in the denominator. So the ones where the term is in the denominator, you make it a negative, right? All right, so next we're going to take our little derivative here. So doing the power rule, x squared will become 2x to the first power because you're multiplying the 2 to the front and taking 1 off the power. Next one here, we're going to multiply the 1/3 to the front, and then we're going to take 1 away from 1/3, and we end up with negative 2/3. And then finally, we take the derivative of 2, and we get 0. You don't have to write plus 0. I'm just doing that just to illustrate what I'm saying. Next, we have y prime equals 2x. I'm going to simplify this expression here. So it's going to be 5/3 x to the negative 2/3. And I'm not going to write the plus 0 this time. Now this is an okay answer, but another way that this thing could be written is like this, as you guys know. Or another way that it may be written is like this. Okay, so those are all acceptable ways of writing it. Let's look at our multiple choice here and see which option it is. It looks to me like they went ahead with this version, and the answer would be A. All right, go ahead and move on to number 4. All right, so on number 4, it says, find the equation of the line tangent to the function at a given point. Your answer should be in slope-intercept form. Now, what this means is that they do want you to simplify it this time. So, and slope-intercept form is this. So they want your final answer to look like that. All right. So let's go ahead and begin. Now, to find the equation of a tangent line, you need 3 things. You need an x, you need a y, and you need a slope. Now, on this problem, I've told you the x and the y, so that saves us a little bit of work. When we were doing it in class, we had to find the y value also by plugging the x value into the original function. But in this case, they're actually giving us the y value, so that's nice. So I'm going to put a 2 right here for the x and a negative 1/2 for the y. The next thing I do is need to find that slope. Now, to find the slope, it's a 2-step process. The first thing we need to do is take the derivative of this function here. Okay, so let's go ahead and do that. The derivative of x squared over 2. So I'm going to multiply the 2 to the front of the x and take 1 away from the power, so I get 2x, but I still have that 2 on the bottom. And then when I take the derivative of this, that's the constant multiple rule, so I'm just going to be left with 3. And then finally, this is a constant, the 7/2, so that's just 0. These can be reduced, and I end up with a nice simple looking derivative of x minus 3. Now, if I want to find my slope, the second step after you take the derivative is to plug in the x value that they give you. So I'm going to plug in my x value, and I end up with 2 minus 3, which is negative 1, so my slope is negative 1. And I'm ready to go ahead and write my slope-intercept form. So I'm going to put my slope here, I'm going to put my x value here, and I'm going to put my y value here. Now, typically, when we're doing this in class, I've just let you guys leave it like this, because that's typically what all you need to do on an FRQ question. But on multiple choices, you do have to simplify sometimes, and in this case, we do, because they do want it in slope-intercept form. So I'm going to distribute here, and that's going to give me y equals negative x plus 2 minus 1/2, right? And then we're going to need to combine these numbers here. Now I noticed in class some of us are a little rusty with working with fractions, so I'll go ahead and show you how to combine those. First of all, you want to make that 2 over 1, that 2, a 2 over 1. Next, you want to multiply the top and the bottom by 2 so that they have a common denominator. Next, we can go ahead and do the subtraction here. 4 minus 1 is 3 over 2. So by putting those together, I end up with a final answer of y equals negative x plus 3 over 2. Okay, and that would be option B here. We'll move on to number 5. I meant number 6. We're not doing the odds, we're doing the evens. So let's do number 6. So differentiate each function with respect to x. So in this case, notice I've got two functions being multiplied together. And so if I want to find that derivative, that would be the product rule. And according to the product rule, if I call this a and this b, then when I try to take my derivative, it's going to have the form. Now notice that the instructions didn't tell you to do the product rule. You have to recognize that based on the way the function is written. It's written as a product, and therefore we know we're going to use the product rule. All right, so a prime would be the derivative of 3x squared plus 5. The derivative of 3x squared is 6x, and the 5 just goes away because it's a constant. B is going the next blank here, and b is not a prime in this case, so it's just going to stay exactly the same. Next, we're going to put the a here. Once again, we're not taking a derivative. We're just writing it exactly as it appears. The last blank is going to be b prime, where we take the derivative of the b function here, which is going to be 12x squared using the power rule. And then the 5 goes away because negative 5 is just a constant. And then our job is to find the answer. Now, this is a multiple choice question, and we have to be careful because there's different ways this could be written. Here's what has to be the case. 6x has to be multiplied with 4x cubed minus 5. And this one, 3x squared plus 5, has to be multiplied with 12x squared. The order doesn't matter at all. Just so long as those two sets of parentheses are grouped, then we're good. So let's take a look here. Here I see that 3x squared plus 5 is being multiplied by 12x squared. That's this guy. And over here we have 4x cubed minus 5 is being multiplied by 6. That's this guy, so D would be our answer. So it is in a little bit of a different order than what I had written, but the order is not important so much as the groupings there of the factors. All right, let's go ahead and move on to number 8. Once again, it just tells us to differentiate. It doesn't tell us how to differentiate. You need to recognize that this is a quotient, and therefore we're going to be using the quotient rule. And according to the quotient rule, we're going to be doing the old low d high minus high d low, drawing a line and square below. So low is 2x minus 4. D high is 4x cubed. High is x to the 4th. D low is 8x cubed. And then squaring the below means we're just going to take 2x to the 4th minus 4 and have it squared. And now we're looking for the one that matches this. And that seems to be option, no, it's not B. I got tricked there. It's not B. Where is it? It looks like it's going to be this guy here, D. It was almost B because they had the numerator right, but they didn't have the denominator right. So there we go. Option D is the solution. But move on to number 10. For each problem, find the indicated derivative with respect to x. So here's my function, and they're asking me to find a derivative, but this is not just any derivative. This is a third derivative. So that means basically we're going to take the derivative, and then we're going to take the derivative of the derivative, and then we're going to take the derivative of the derivative of the derivative, which means we're taking the derivative 3 times, right? So here we go. Let's start by doing the first derivative. Derivative of 3x to the 5th would be 15x to the 4th. The derivative of 2x to the 4th would be 8x cubed, and the derivative of x squared would be 2x. There's my first derivative. Now we need to find the second derivative. So the derivative of that is going to be 60x cubed plus the derivative of that is going to be 24x squared, and the derivative of that is going to be minus 2. And then finally, we're on our third derivative here. The derivative of that is going to be 180x squared. The derivative of that is going to be 48x, and then this just goes away because it's a 0. So I'm looking for that option there, and that would be option A. All right, let's go ahead and move on to number 12. Once again, they're just telling us to differentiate, but we need to recognize what rule to use. And as you guys can see here, this is a chain rule because I have an inside function here, 5x cubed plus 3, as well as an outside function, which is highlighted in blue here, something to the power of 5. So there's my inside function and my outside function. Now, according to the chain rule, the derivative of a composite function like that is going to be the derivative of the inside, or outside, I should say. I think that's how I did it in class. I did that one first. The derivative of the outside function multiplied by the derivative of the inside function. Okay, so here we go. The derivative of the outside function. If you have something to the fifth power, that's a power rule. So you put the 5 in the front and you take 1 away from the power. And there's our derivative of the outside. And when you do the derivative of the outside, the inside part of that is going to stay exactly the same. Now we're going to do the derivative of the inside function, 5x cubed plus 3. The derivative of 5x cubed is 15x squared. Let me change my color to orange real quick. 15x squared. And then the derivative of 3 is 0, so that's all I'm left with. And in our notes, I simplified it a little bit more by multiplying this times this, but you don't need to. You can see that the answer is exactly how we have it now on option C. There we go. Chain rule. This is another chain rule problem on number 14 here. It just looks a little bit different because we're dealing with a radical function here, and we talked about those as well. The way that you're going to deal with those is you're going to start by rewriting it as a power instead of a radical. So instead of the fifth root of x to the fifth plus 5, we're doing x to the fifth plus 5 raised to the 1/5 power. After that, we're going to go ahead and do the chain rule. So my outside function is this piece here being raised to the 1/5. My inside function is this. So to find my derivative, we're going to do derivative of the outside multiplied by the derivative of the inside. So here we go. The outside is a power function. So I'm going to multiply the 1/5 to the front, and I'm going to take 1 away from the power, and then we leave the inside the same. And then to find the derivative of the inside, the derivative of this thing here is 5x to the 4th, and the derivative of 5 is 0. And it looks like it's probably just going to be left in unsimplified form again, so option A is the solution. All right, go ahead and move on to number 16. 16 has a lot. Now on your quiz, you're only going to have one of these, but I want to make sure that you're prepared for all of them. So here we go. Let's do it. For part 1, we're dealing with this function. So h prime is going to be equal to f prime plus g prime. And then we're going to go ahead and plug the 4 into the h function there, which means I'm going to plug the 4 in over here as well. Oops, that's B. Fix that real quick. And then after that, we just look at our table. f prime of 4 is 1, and g prime of 4 is negative 1. And so by putting those together, we end up with 0 as our final answer. Let's take a look at part 2. On part 2, h prime of x is going to be equal to f prime of x minus g prime of x. So according to the sum and difference rule on parts 1 and 2, when you have a function that is two functions being added together, the derivative is just taking the derivative of each piece separately. That's what I've done. Next, we plug in our number after we take the derivative. And then we go ahead and use the table. F prime of 2 is negative 1/2. G prime of 2 is 0. And so the answer is negative 1/2. All right, let's go ahead and take a look at part 3. All right, now in part 3, we have a product function there. We have two functions, f and g, being multiplied together. And so to find the derivative of this one, we need to do the product rule, which is going to be f prime of x times g plus f of x times g prime of x. Then we go ahead and plug the number in that they're giving us, which in this case is 1. And then we go ahead and evaluate from there. F prime of 1 is going to be negative 2 times g of 1. G of 1 is 2 plus f of 1, which is 3, and g prime of 1, which is, and we end up with negative 4 plus 6, which is 2. And that's the answer to part 3. All right, moving on to part 4. On part 4, we have a quotient function. We have f of x over g of x. And so h prime is going to be the quotient rule. Low, d high, minus high, low. Draw a line and square below. My below is g of x. My low is g of x. D high is f prime. High is f. And d low is gx. G prime of x, I should say. Next, we're going to go ahead and plug in the number they give us, which is 2. So h prime of 2 in this case then is going to be g of 2 times f prime of 2 minus f of 2 times g prime of 2 all over g of 2 squared. Now we're going to use our table to fill these in. G of 2 is 4. F prime of 2 is a negative half. That in parentheses. F of 2 is 1. And g prime of 2 is 0. On the bottom, g of 2 is 4, and that's going to be squared. Now we just got to simplify. 4 times a negative half. Think of that as 4 over 1. 4 times a negative 1 is negative 4. 1 times 2 is 2. So I have negative 4 over 2, which simplifies to negative 2. 1 times 0 is 0. And 4 squared is 16. So I end up with negative 2 over 16, which reduces to negative 1/8 as a final answer there. All right, go move on to part 5. Part 5 is a chain rule because I have an inside function and an outside function. My outside function is something being squared, and my inside function is f of x. So if I wanted to find my derivative here, we're going to be doing outside times inside. The derivative of the outside is 2 parentheses 1. Guess I could do it in blue. 2 parentheses 1. And we don't change the inside when we do that. And then next we have the inside. The derivative of the inside is f prime. So there's our derivative, and now we're ready to move on to do the plugging in of the number that they give us. The number they give us is 1. So I've got 2 parentheses f of 1. I don't really need that power there, so I think I'll just leave it off. And then f prime of 1 goes here. So let's go ahead and simplify this a little bit. First of all, f of 1. F of 1 is 3. So I've got 2 times 3 there. Then we have f prime of 1, which is negative 2. And we're ready to go ahead and just multiply all this together, and you get negative 12. Final answer. All right, let's go ahead and take a look at our last one here. Number 6, it's another chain rule problem, just a little bit different. So for this particular problem, we have h of x to the outside function, which is technical difficulty there. All right, my outside function is f, and my inside function is g. So we're going to go ahead and do our derivative now. H prime of x is going to be equal to the outside multiplied by the inside. The derivative of f is just, oops, wrong color. The derivative of f is going to be f prime. Still wrong color. Be nice if when I clicked on it would actually. And then the inside is going to stay the same. And then we multiply by the derivative of the inside. Derivative of g is going to be g prime. And now we're ready to go ahead and plug in the number that they gave us, which in this case is 3. So we're going to be putting 3 in there. Oops, like a minus. All right. So first of all, let's do g of 3. What's g of 3? G of 3 is 2. So if I replace that, I'm going to end up with f prime of 2. And then g prime of 3 is negative 3 halves. So just put that in parentheses. Now I need to find f prime of 2. F prime of 2 is a negative half. And now I'm ready to go ahead and just do my multiplication. So top times top is going to be 3. Bottom times bottom is 4. Notice they're both negatives, so the negatives cancel, and I'm left with 3 4. Right. Last thing you guys want to do to prepare for your quiz is you want to look back at your FRQs that we did last weekend. This will make up 25% of your test, so that's a big amount. So make sure that you guys are prepared. Basically, I'm going to pick some problems from that FRQ, and your job is going to be to do them. And they're going to look just like that. They're just going to be slightly different numbers, maybe a slightly different word problem, but the process you would use to solve it will be the same. So go ahead and take a look back at those FRQs to prepare for that 25% of your quiz. The rest of the quiz is all going to be worth 1 point each. So there's 6 multiple choice questions on your quiz, and then this one is going to be worth 2 points. Now, that doesn't sound like much, but understand that's a 25% value of the quiz, so that is a big deal. Bring your graphing calculators if you have them, because some of the FRQs we did over the weekend required a graphing calculator. Of course, I have my own graphing calculators, but if you're going to use mine, just make sure you know how to use them. All right. Other than that, we'll see you guys on Wednesday for your quiz. Have a good one.